Hello, everybody, and thank you for joining the Data Architecture Virtual Group for May 2021. We are happy to have Ryan Adams back with us for the first time in a while, talking about history tracking with temporal tables. We're real happy to have Ryan back. My name is Kenny Neal, and I am the co-leader of this group along with Rob Canzaneri. If you're interested in speaking for our group, you can email us davg@davg.org. And you'll find links there to like our YouTube page, and you can find some of our past recordings. We're sponsored continually by HVR Software. We're happy to have them back with us for, I don't even remember what year this is, and we're really happy to introduce a new sponsor as of yesterday, Rubrik. And so with that, Nick from Rubrik would like to say a few words about what they do and their upcoming Forward conference. So take it away, Nick.
Go ahead, Nick.
Hey guys, thanks so much for having me. I really appreciate you guys giving me a little bit of time here. I know, very, very important. I love that you guys got a nice community built here. It's amazing. Rob and Kenny were telling me all about it, and very excited to play a part, moving forward, being sponsored for you guys. I did want to mention, if you guys don't know who Rubrik is a data management company. We are focused on almost all the workloads that are kind of in the enterprise today. Specifically with a good portion of that around SQL and Oracle and around the databases. So I know Kenny and Rob use this on a regular basis, and definitely take advantage of some of our technology. So if you're not interested, or you don't know exactly who we are, we certainly have an opportunity to kind of deep dive with you at any point in time. But more importantly, next week is our annual Rubrik conference. It's called Rubrik Forward 2021. It's happening May 18th through the 20th. It is free. It's online. It's virtual. There are going to be several different talk tracks around data protection, data management, around cloud, around security, all tenets of what Rubrik touches today in the enterprise. So if you guys have some extra time, I sent a link to Kenny, so maybe he'll shoot that out to everyone. Feel free to register. Like I said, it's free. Be glad to have you guys join us and understand a little bit more about who Rubrik is and how it may be impactful to your business and to your work life. So thanks again for the time, guys. I'm going to be in and out. I know you want to hear a whole lot from everyone on the sponsorship side, but appreciate you guys giving us a little bit of time to tell you who we are and invite you to Rubrik Forward. So thanks so much.
Thank you, Nick. I'm gonna mute out, Kenny, so you can take over. All right.
All right. Thanks, Rob. Thanks, Nick. And so without further ado, I'd like to reintroduce Ryan Adams. Ryan is a senior community engineer for Microsoft. His focus on data and AI allows him to work with many technologies like SQL, Azure SQL IaaS, PaaS, Databricks, and Synapse Analytics. Previously, Ryan was a Microsoft Data Platform MVP, and he spent 19 years working for a Fortune 100 company. Thank you, Ryan, and I'm going to mute out and take it away.
Thank you, Kenny and Rob. Appreciate that. Appreciate you guys inviting me to come speak to the group today a little bit and talk about temporal tables. And like Kenny said, my name is Ryan Adams. I'm a senior customer engineer here at Microsoft. I work with most of our, I work in the data and AI space, but I typically work mostly with our healthcare customers. I am married. I've got 2 daughters. My oldest is 14. My youngest is 12. I was an MVP before I joined, and obviously a lot of this just means I like to talk a lot. And then, pre-COVID times, I enjoyed playing hockey, and I was finally able to get back on the ice a little bit a couple of times. I haven't played yet, but I was at least able to get on the ice the first time in well over a year recently, and so that was really nice to be able to do that. And that's kind of what I do in my spare time. So let's talk about temporal tables, and all of us are coming from different levels of knowledge here. Some of us may not have used them at all. Some of us may have played around with them and kind of have a little bit of an idea of what they are and what they're used for, and just the different ways that we can use these. And they're system version tables, right? The idea here is we're keeping a full historical record of any data change that happens in a particular table. And it is a full record. So we're keeping the whole row. So every bit of data, every time we make a change, the old version of that row, what it was prior to us updating it, we're keeping a copy of that. So when we do that, we have both the temporal table, which is our table, our primary table that we have chosen to use, and we have a historical table. And we tie these two tables together. Now, you don't have to do this. This is all happens behind the scenes. You don't have to worry about tying these things together, depending on how you do it. I'll show you a couple different ways that we can either let the system handle tying them together. You can't actually tie them together yourself. It's up to you how you want to do that. But it's nice to be able to have this option available to us. And then we've got some columns that we have to add. So the idea is if we're going to keep historical copies of these records, what we really need to know and track is for what time range were they valid? Right? When did the record get inserted? That was the valid start time. And then once we either deleted it or we made an update to it, the version of that is now time boxed as an end time, so that we can see that at any given point in time, a record was valid for the timestamp period that we have defined. So these allow us to do that. Now, it does add a history table to the user table, right? Because we are keeping the full history of every change that we make here. And those old rows are going to get moved over. And I'll show you, it depends on the operation. So I'll show you what happens if you do an insert. I'll show you what happens if you do a delete. And then I'll also show you, what happens if you do an update. How exactly does that work? We'll talk about how that operates. So I've got a little bit of a diagram I can show you on how that works. Now, the nice thing is the current tables, the queries that you have for your current table, you don't have to change them. That's probably one of the best things about temporal tables. So if I'm looking at keeping this versioning and enabling this versioning on a particular table, the current queries that are coming into the table, I don't have to change them. So from an app development standpoint, that's absolutely brilliant that I don't need to worry about that, because it means that I don't have to go back and make changes to my queries. I don't have to refactor anything. All of that stuff still remains the same, but it's going to give me some additional abilities on top of that. So that's really great. And anytime you can do something that doesn't require a development change, that's obviously a great thing, right? We do have some new TSQL syntax. And I'll show you what the syntax are. There's, I think, 4 or 5 of them, and we'll walk through each of them that you can use that allows us to be able to grab this history. So it's not like you're rolling your own where I've got to go in and join these 2 tables together in order to grab, the versions that I needed for whatever time frame I needed. I don't have to go grab that out of the history table and join it to the current table. We don't need to worry about that. That's all handled by the system for us. So there are a few places where we can use temporal tables that they come in handy. The first one's auditing, but this isn't auditing like you think it is. When I hear auditing, usually what I'm thinking is I want to track who did what. I'm trying to protect my data. I'm trying to track it and see what's going on. That's not what this is, right? This is not a replacement for SQL Server auditing. What we mean by auditing is that you could go back and find out, hey, 6 months ago, what did this record look like? Was there any changes between now and then, or how many changes happened to this record in the last 6 months? So we're doing auditing from the standpoint of the actual data itself that we can go back and look at. What we can't see is who made that change. In order to do that, we need to use SQL Server auditing for that. So don't confuse the two here, but when we talk about auditing, it's just the fact that we're keeping an entire copy of the whole record itself. It's also great to use for change tracking. This is really great for data warehousing, so that we can use some data and it kind of plays in the next one, right? This works fantastic for a type 2 slowly changing dimension. Because we're keeping a full history of all the rows, instead of having to roll our own, if we wanted to use slowly changing dimensions here, this would be a great place to use a temporal table. It makes life a lot easier instead of having to go in and create this ourselves. Not to include if you do, start using nasty things like triggers and all that kind of good stuff. Right? We don't have to implement those types of procedures, which are going to cost us more development time anyway to create them. This is kind of all handled in the package. Anytime you're using anything time specific, If I'm trying to grab any chunk of time, whether that is what is it on this specific date, what is it between these two dates, what is it on this list of 5 or 6, 7 dates, any type of report is going to pull stuff in and look at things based on date. This is a great avenue and tool in our toolbox to use for those types of reports. It'll make them a lot easier and a bit more efficient. The other cool thing is, since we're keeping the entire copy of the row, if somebody were to go in and make a mistake, right? They deleted some rows, updated some rows, they messed up their predicate, left off the whole where clause completely, whatever it happened to be. The good news is instead of like, oh man, great, this guy went in and dropped this table, I'm gonna have to go do a database restore in order to get this table back. Well, we don't have to do that here. If it's a temporal table, since we have the old version of the rows in the history table, all we have to do is go query them out of the history table and put them right back in the temporal table. So that makes things a whole lot easier to handle situations like that, where we have errors or issues within our data. We've made some mistakes. We want to be able to go back and correct those mistakes. This is a super easy way to do that because we actually have the full previous versions of everything available. And again, I kind of talked a little bit about the last one here, right? So we're not having to roll your own by creating triggers and maintaining the whole history table and all that. This is all built in and maintained for us. So we've got some pretty good advantages there. Now, when we go create these, and I'll show you how this works when I break out my VM here in a minute, there's a few different ways. So one is when you create the table brand new, you can define it as a temporal table right out of the gate. But it doesn't have to only be that way, right? Because a lot of times we don't have that luxury of starting from greenfield. Sometimes, we're within an existing system, and this is something we want to take advantage of in an existing system. And you can do that. So we can take a history table. You have to create the history table first, just the schema. And then we can tag that and kind of join that up to the existing table that we want to make temporal. And of course, the inverse of that is true as well. If we had an existing table and we also had an existing history table, we could rejoin those back together as well. So you might already have the existing table, you might already have a history table that you kind of did yourself, and now you're wanting to, instead of managing and maintaining that yourself, or maybe you want to get rid of the overhead of triggers or whatever you're using there to maintain that, you want to switch over to temporal tables, no problem, we can do that. You can take an existing table and an existing history table, we can put those and join those two together. It's not a problem. Now, there are some requirements here in order for us to be able to do this. The first is the schema, right? The schema has to match. You can't have a column in one table and not in the other. So if we're going to take a temporal table and a history table, when we match them together, the columns have to be exactly identical. And so we can't have an additional column in one that's not in the other. They have to match. The schema needs to match across these columns. Now, even though the schema has to match, it doesn't mean that the physical structure necessarily has to match, meaning that I could do some partitioning here if I wanted to. And I could even say, take the history table, because the history table might be drastically larger than the actual temporal table because I'm keeping the full history of everything over time. And because I'm keeping things by time, I may want to partition that out. So we could take advantage of that from a performance standpoint. Using partition elimination will be helpful for some of our queries. And because we're partitioning, that also means that I could put it on a different file group and locate it on a different physical drive. So if I had a slower IO subsystem, maybe I might want that for the history table because I don't query it that often. And so if I'm balancing my performance and my speed, or my performance and my cost, I might look at it and go, okay, it costs me less to put it on the slower IO, but that's okay because I don't really need the performance out of the history table, but I do out of the temporal table. So that might need to be on SSD drives. And you can do that. We can split these out, putting them on different file groups, and you can put one on a different subsystem, IO subsystem than the other one. So it's just the columns that need to match. We can index them differently too, which is super handy to be able to have. That's something that, if you were, because we're talking about reporting, these can be really handy to use for reporting. One of the other technologies that we have that's really handy for reporting is availability groups, because you can have a secondary replica, another server that's got a full copy of your data, and you can read from it. It's very handy to be able to do that. But in that scenario, the indexes can't be different, which is disappointing because our read workload and our OLTP, or even the data warehousing, ETL loads, they're not the same, right? The reports that we write are all read. There's not doing updates and inserts. I'm not, that is a completely different workload that I'm using, and I may be pulling and joining tables and information together differently there. It would be nice if I could index that differently. With availability group, you don't have that choice. We can't do that. And by the way, if you guys have questions anytime, feel free to use the chat window. Happy to answer any questions. Don't worry about interrupting me or anything. So the indexes can be different. That's really nice to have that advantage here, because we don't have that advantage with some of the other technologies in our toolbox. And column store indexes are supported. Also a great thing here, because again, large table, right? We're keeping a large history. It's going to have a large amount of data in it. So if we can put column store indexes on there to help compress that data down, it'll make it much more efficient when we go to actually query the data out. So a very nice additional weapon in the toolbox that we can use here to make things better and much speedier. So here's a little bit of syntax on creating this. So if I was going to create a brand new table starting greenfield here, and I wanted to create this department field here. So I'm doing create table department. And I've got 6 columns here. And what I'm really interested in are these ones that I have highlighted in yellow here, these last 3. This is a requirement. You'll notice that the date time is a date time 2. That is also a hard requirement. So if we're going to create a table, we're planning on it being temporal, that's one of the first requirements we have, is that we need to have 2 columns that are date time 2s to represent the start and end time of the validity of any given record at any given moment. And so you'll notice that I'm using, and you can call these columns whatever you want. Obviously, using sys start, sys end, or something with the word start and end in it would make sense for us from a human standpoint, that I could look at this and go, oh, I pretty much know what that column's got in it. You could name this something completely weird if you wanted to. It doesn't really matter. I wouldn't suggest that you do that, but this is just a column name. Got to have the date time 2 data type. And then this last piece will always be the same, generated always as row start. And of course, the end will also be as row end. So this is denoting for this table that this is going to be temporal. This is going to be the start and the end time of the validity of a row. And then we tie that all together by saying period for system time. And then we put the name of the 2 columns, the start and end, in that order, start and end, inside of our parentheses here. And then there is a with clause that we also need to define here, and it says with system versioning equals on. There's also a clause here that says history table equals and names the history table. That's actually not required. If you leave that off, the with system versioning part is required. You do have to have that, but the history table part, you can actually leave that off and it'll create a history table for you. All right, but you don't really have control over the name of the table, which is the advantage to using it here in this fashion, is that I get to determine exactly which table is going to be the history table and what the name of that table is. If you leave it up to the system, it gives us a nice, pretty. It actually gives you the table number as part of the table name or table ID. I'll show you what that looks like here shortly. You can also do an alter. So if you have an existing table, let's say our department table already existed, I can also just do an alter table on my department table, and then I can add the columns. So add a valid from, add a valid to, right? I could have called it sys start and sys end if I wanted to. It's the same difference. Date time 2, generated always as row start, generated always as row end. And yes, I do have the keyword hidden on here at the end. I'm going to explain the hidden keyword and what that does here in just a little bit. So hang tight on that one. But it's not a problem to go in and do this alter, add the columns that we need, and again, tell it what the period for system time is, and then give it those columns. And then you got to do 2 alter statements, the second one being turning the actual versioning on and telling it what the history table is if you want to define the history table yourself, as opposed to letting the system do it for you. So how does this whole DML work here? So I've got my temporal table over here on the left, and I've got my history table over on the right, and I've got my user down here at the bottom. And he's going to do an insert. That's pretty simple. The insert just goes into my table. Right? This is the actual current table data that I have right now. In insert, there's nothing special that happens here. And that's part of the cool thing here is there's no code changes. Right? I don't have to go in and change my existing code if this table was already here. Inserts and reads out of here, they don't work any differently. This is the really nice part of not having to change the code. If he does an update or a delete, the update goes into the temporal table. We take the current version that's in there and move it over to the history table. And then we insert the new version with the updates that you've made. If you do a delete, then we just move it over to the history table, obviously, where it would no longer exist in our primary table here. This all happens behind the scenes. This is all automatic, so there's nothing special that you need to do to ensure that these rows are going to move from the current view of the table into the history table. And of course, any regular queries, again, nothing that you need to change here. You're just querying the table just like you always did. So nothing new here. But you can also say, now that I've turned this history on, is go, okay, well, that's great for current data, but I am also wanting to make sure that I can do some other things like query the history table. And you can do that. And truthfully, all this really does behind the scenes, if you want to pull back the curtains and know how we do this underneath the hood, we do a union. You can actually just look at the query plan when you go query one of these, and you can clearly see the union right in the execution plan. So we're going and grabbing whatever it is that you're requesting from the history table, grabbing whatever it is you're requesting from the temporal table, and then we just union those together to give you your result set. But you don't have to do that. And we give you some really handy tools, some syntax that we'll talk about here that allows for making this a little bit easier. And the first one here is as of. Now you'll notice here that the as of is looking for the start time to be less than or equal to the date time, and the end time to be greater than the date time. So in this example, if I wanted to select the state out of the employee table for system time as of June 15th of 2011, and this is 3 records in my current table, right? We don't grab the first one. It's valid from January 1st of 2010 to December 31st of 2010, so it's covering all of 2010. But my date is June 15th of 2011. It's in the middle of 2011. So we're not going to grab this row. The second row, however, we are going to grab this date out of this row because this covers all of 2011. And of course, June is right smack in the middle, so we're definitely going to be grabbing that row. But Florida, we don't, because it's grabbing 2012. So what we're saying is go grab me the version of this record as it existed as of this date. And so we're looking to go grab in the history table and find all records that match and existed as of June 15th of 2011. The next one we have is from to. So we're selecting the state here from our employee table again, where the system time is anywhere from January 1st of 2010 to December 31st of 2011. So that's covering 2 years worth of time. We want to go grab the state of every record that exists here. Now, in this example, I've only got 4. But let's take a look at the records, right? So this first record is January 1st of 2010 to December 31st of 2010. So that's definitely going to be included. That's all of 2010. And we started at January 1st of 2010, right? So it has to be less than the end time, but it has to be greater than the start time. So we get that included. Iowa gets included because we're going all the way to the end of December, and this covers all of 2011. And we're looking at December of 2011. But the interesting one here is Texas. we don't actually pull this one back. The start time is December 31st of 2011. Now, although we said from January of 2010 to December 31st of 2011, it is exclusive of the end date time. So we don't include any records that start on the day that we define as the end date. So keep that in mind that this one does not include that. The next one here is between and. This one is exactly like the one prior. The difference here is that the start time needs to be less than and also equal to the end date time. So in this instance, we actually would get Texas back because our end time that we wanted to go grab is equal to the start time here. It won't grab anything else in here, but because this record was valid on December 31st, we are including that time. So that's the big thing is if you don't want to include it, going back to the previous slide, we're using from and to. If we do want to include that, then we use between and. The next one is contained in. This one's probably pretty self-explanatory. It kind of does exactly what you would think it would do. An example here is we're looking for times that are contained in this list. And I've got, obviously I can have more than 2 dates in this list, but I'm looking for January 1st of 2010 and December 31st of 2011. So go grab me any states out of this employee table where the record was valid on January 1st of 2010. Well, this one is because it started on January 1st of 2010. And it is, you notice that both of these operators here are less than and equal on both sides. So it'll grab that one, and then December 31st of 2011, the end time happens to equal that, so we're going to grab Iowa. So that's how contained in works. And then the very last one is, this one you'll use probably fairly often when you're going in and just trying to get to know the data, you're trying to query and test things out, and you just want to grab everything. So all means all, right? So grab the states from the employee table where system time all means it's going to grab everything. And it's grabbing everything from all of these queries are going to grab anything that's valid in both the history table and the current temporal table. So it's not exclusionary of one or the other. It's not like we're just looking at the history table to grab history and historical type stuff. It will grab from both of those. So when I go grab this all, it's going to grab everything out of both tables. So obviously, if you had large tables and you've been keeping history for a while, using system time all, probably not going to be a great query. It's going to take some time to come back because you've got a lot of data in there. So let's go ahead and take a look at how this stuff works. It's always more fun to go in and figure out how this stuff actually works. So I'm going to go kind of full screen here. If this is not legible and it's too small, let me know. I can make this a little bit bigger. Just throw it in the chat window and say, please make it bigger. But hopefully you guys will be able to read some of this. I'm just going to use AdventureWorks 2016, so nothing special here. We're just using the 2016 sample database. And what I'm going to do is we're going to go in and let me run this because this first one just kind of sets up my demo here. I'll just kind of get everything kind of cleaned up. And what we want to do is we want to start off by creating a temporal table. So I'm using AdventureWorks and I'm saying create table. And I'm going to use it. We're going to call this like a person table, person temporal. And I've got some list of columns here, but the important columns are the ones that I absolutely needed to make sure I had were these two. I have to have start time and end time. Both of those are absolutely required for me to be able to use. And you'll notice that again, it does have to be date time too. I'm using system start time as my row start, using end time as my row end. We tie them together here, saying period for system time, system start, and system end are the columns that I've chosen to use here. And then I'm going to use system versioning on. And you'll notice I did not, and we'll come back to this, I did not define a history table here. because I want us to be able to see what happens if you don't, because it still works, it still runs. So let me run this. It's going to create my temporal table for me. And then what I'm doing down here at the end is I'm just selecting some things from sys.tables where the temporal type is greater than 0, meaning it is a temporal table. So this is going to let me go in and get an idea of what in my system is actually a temporal table. And let me open up my Zoom. I didn't have that running yet. So when we take a look at the results here, what we end up seeing is, you know what, these tables actually are tied together. It did create a history table. I didn't define the history table, so it created one for me. And let's expand out this column because I want you to see the name that it uses here. And I think it'll be pretty obvious where we grab the name from. If these tables are tied together, it's called MS SQL Temporal Table, Temporal History for this number. This number matches the object ID of the temporal table. So this is how we know that these two are linked together. So it's kind of nice that it's right here in the name of the table, that there's an object ID in here, which makes it very easy for me to go look up that object ID to figure out what table it's actually married to. It also gives me a description down here, so I can see which one is considered a history table, and then I can see which one is a system versioned temporal table. So that's kind of cool to be able to see that. We'll loop back and talk a little bit more about that here in a minute because I want you to be able to see, you know, what happens to these tables when we start messing around with some stuff. So let's do this. I want to figure out what type of operations are and are not available here. So what I'm going to do is I'm going to take my temporal table, my person temporal. We're going to run this query and it just says truncate the table. Let's see what happens. But when I run this, I get an error message back and it says truncate failed on the table because it's not a supported operation on a system version table, right? You can't go into a system version table. If you've got temporal turned on, we can't just truncate the table. It doesn't allow us to do that. Right? We would have to break that relationship between the primary table and the history table before we did something like that. So you say, okay, great, I can't truncate it, but I really kind of want to get rid of it. So what if I try and do a drop? Well, if I try and do a drop, we get back the exact same error message that says, nope, guess what? You can't. This is not a supported operation on a system version temporal table. So when we turn this on, note that you can't just truncate stuff and you can't just drop tables. All right, now we can get rid of it, and we can do that simply by running this alter statement. This alter statement says, alter the table, set system versioning off. As soon as I set versioning off, it takes the two tables and breaks them. Now that relationship's broken. It's not there anymore between the temporal table and the history table. Once I break that, you'll notice that when I run this, I am actually able to successfully truncate the table, right? Both of these commands, the alter and the truncate, both completed successfully. So I can truncate as soon as I break the history table and turn versioning off. Okay, so we see what that kind of happens. Now let's turn it back on. So I'm going to run this. I'm just saying the same thing. Before up here, I ran system versioning off. I'll do the same thing, alter the table, turn versioning on. And then I'm going to query sys.tables again in order to see what's inside that I have here. And keep in mind that I'm just looking in sys.tables and looking for everything where the temporal type is greater than 0. And sure enough, if I look in here, I see this. I'll zoom in here in a second once I get that column spread out. This looks a little bit different though. I mean, I can see that this is my system version table. I can see this is my history table. But the name here is a little bit longer than what I expected last time. It still has this object ID, which is the table 841953350, matches my object ID here. But it has tacked on this piece at the end, 9DB66077. The reason it had to do that is because the table name with the object ID was already taken. We'd already used that. But interestingly enough, we don't see that here when we query sys.tables looking for anything where a temporal type happens to be greater than 0, which is what we're doing here. Okay, that's interesting. Let's see what we can figure out what's happening with that. When I first started and I created this table, I created in a schema called _demo. If I go in and I query sys.tables and I just grab it where the schema equals _demo, now what you're going to notice is, oh, let me take the column here. Let's spread this column back out. Zoom back in. You'll notice that that's because the original history table never got deleted. So if you turn versioning off and you turn it back on without defining what the history table is going to be, it creates a new history table. And what's more interesting is that not only does it create a new history table, and this also gets confusing, right? Because although I can see like the IDs match here, well, which one's currently valid? Well, I can see that it's not this one. This one does tell me that it is a non-temporal table. Right, this is my old history table. It's just sitting there like a regular table all by itself. Right, because I didn't join it back up. So as soon as I turned it back on, boom, created a new history table. The old history table is still sitting there, all on its lonesome. Now it doesn't have to be that way. And this is kind of fun. So I'm gonna do it again just for fun, right? So alter table, turn versioning off, turn right around and turn versioning back on, run the same query again, and then you're gonna see the exact same thing happen again. But look, it creates yet another history table. So now I basically have, if you will, 2 orphaned history tables because these aren't temporal. So it's kind of interesting, but that's really good to note because what ends up happening now is that I've got orphan tables out here, right? Or maybe I didn't really want this to happen. I actually wanted to reuse that. Maybe I broke this for a reason, and then I wanted to put it back. So I'm going to turn versioning off. I'm going to go ahead and drop this table, kind of clean up a little bit here. Once I do that and I drop the table, if I go take a look at everything inside my schema again, I can go get the remaining tables. These are the orphan tables. I'm just creating some drop statements here where we could go in and kind of get rid of these. So what I'm going to do is I'm going to copy these out, paste them on top of this line. Go grab this row. We're going to paste it on top of this line here, just so we can go get rid of these tables because we're obviously not using these. These are the old tables. We need to go ahead and drop those and get rid of them. So I'm going to get rid of those extra history tables so they're not there. So what if I wanted to create this and thought, you know what, I really am not thrilled about the naming convention that we use here. What if I wanted to give it my own name, which would make sense, right? If I'm creating a table like we're doing here called person temporal, if I wanted to just go grab a list of all my tables, wouldn't it be nice if I called it person temporal history so that alphabetically these 2 tables would always be listed together if I queried it out or looked at it in Management Studio? That would make life a whole lot easier. It would make it much easier to identify just by looking at the name that this is probably a temporal. Despite the fact that in this example I use the word temporal in the name, but obviously in production you're not going to put the word temporal into your table name. But it would be nice to be able to see this sitting right next to each other. So _history, or just put the word history in here, or however you want to use that. I would encourage you to choose a nomenclature and stick with it, right? The more consistency and standards you have, if you're going to put the word history after it for the name, the name of the table and the word history, use that across the board. Make that a standard in your environment. It'll make things a lot easier. And that's really all I'm doing here, right? The only difference between the create statement that we ran earlier and the create statement that we see here is simply the addition of this history table equals underscore demo person temporal history. And the cool thing about it is like this table doesn't exist right now, right? The temporal doesn't exist. The history table doesn't exist. And I told you that the schema has to match. So if I were to go in and manually create this person temporal history table, I would have to make sure that I use the exact same column names across the board. But here I don't need to do that. This will, just by giving it the name of the table, it'll actually create the table for me. So I'm going to go ahead and run this block. It's going to create the temporal table for me. And then I'm going to take a look inside sys.tables like we've been doing just to get a list of the tables. And sure enough, now we have a temporal history table here, and this has a nice pretty name on it. Now it doesn't have the object ID in the name like the default one was. It was kind of handy that we had the object name or the object ID of the matching temporal table here, just because we could look at that in the name. But here this looks a lot better because these are always going to be sitting next to each other. So it's pretty obvious this is a temporal table. This is probably a much better naming convention to use as opposed to letting the system do it. So this is how we can do this to make sure that we're choosing the name instead of letting the system choose the name. All right, and if I look at the demo schema here, just to show, because we were looking at the schema before, we get the exact same result set that we saw a minute ago. We just see that here's my system version table, here's my history table, here's the two that are named that. But what if I turned it off and turned it back on, right? So before, when I turned it off and back on, I ended up creating a new history table every single time and left me with an orphan history table. And I didn't really want there to be an orphan history table. So how would we handle that? It's pretty easy. So if I do an alter, just like we did before, to turn it off, nothing new there. But when I go to turn system versioning on, you can define the history table. And since I already have one that exists, person temporal history, this should work. And note that it's not creating a new one, right? I didn't delete the old one, right? The old one's still there. All I did was turn it off and turn it right back on. I just told it when I turned it back on which table I wanted to put all the history in. When I do that, I see the exact same results that we've been seeing, right? There's nothing new created here. And you might be thinking to yourself, well, that's because you looked at everything that was a temporal type greater than 0. What if you go look in the schema? Did it happen to leave an orphan table that was called person temporal history? Good question. Let's find out. Let's go here. Let's query the schema and see what result set we get back from that. No, we don't. There's nothing orphaned here, right? This is the entire schema that I created, and it's still just our two tables that we created here, the temporal and the history table. So there's really nothing new going on here. So that's great. So this is a great way that allows me to both make sure that I use a naming convention of my choosing in order to name the history table, and also make sure that I don't have myself end up with an orphan table. And then I'm going to go clean up after myself here. So I'm going to turn versioning off and go drop both of our tables. You notice that I do have to drop them both, right? So if I turn versioning off, that breaks the relationship between the temporal and the temporal history. So now I can actually drop them, but I have to, but now they're individual tables, both separated by themselves. Now that I've broken the relationship. So I'd have to drop them both individually. So Kenny asked, what would happen if you made changes to the base table while system versioning was turned off? And you could. And that actually doesn't alter anything. Now, it depends on the changes you're talking about. If you're talking about DML changes where I went in and like added some rows or something like that, you can still do that, right? That's totally valid to be able to do. Now, that's might throw off your history a little bit because you're cheating the system, right? Because it's not going to know about that. It's also good to know that if you made changes after I turn this off, any changes that I make, any inserts or updates I make to my temporal table, they're not going to be reflected in the history table. So if I'm going to do this to make some changes, right? And one of the examples I could think of here might be that, let's say you needed to make a schema change. I need to add a column to this table. Well, in order for me to do that, they have to match. So I'm going to have to break the temporal table, and then I'm going to have to go add the column to the temporal table, add the column to the history table, and then join them back together. What I want to make sure of though is I probably don't want people making updates and inserts in the system while I'm doing that, because if they are, any changes they make to that temporal table will not be reflected in the history table. Hopefully that answers your question there, Kenny. So create an indexed history table. This is cool because, as I mentioned earlier, we can actually index these separately. Right? There's an excellent chance that I'm going to do this differently than how I had done before, because I have a different read workload. I'm doing, Power BI or reporting services or Crystal or whatever, Excel, whatever you're doing, ad hoc reporting, whatever the case may be. Maybe we would want to create some different indexes here. So what I'm doing here is I'm going to recreate our person temporal table again. Nothing new with the schema. All of this stuff still matches. None of this stuff here is different. That's not new. What is new is I'm creating some indexes, and I'm using column store. So I'm creating a column store index here on the temporal history table. I'm creating a couple non-clustered indexes here across my system start and end times, my business entity ID. So I've got that going on. And this is my history table. So notice that I created my history table first, not my temporal table. Then I decided to go in and create the temporal table. And you have to do this, right? Because if you're going to create these separately, you can't create the temporal table and tie it to the history table if the history table doesn't already exist. So the history table actually has to be created first prior to creating the temporal table that matches, assuming we're doing this greenfield and creating it new. But what is a little bit different here is I've created 3 indexes on the history table. I am not doing that on the primary table. I am creating a non-clustered index here. The first one is across the same 2 columns, system start time and end time. The second one's not, it's across last name and first name. And the column store index is not being created here at all. So as you can see, this command runs successfully, meaning that I have created different indexes on the temporal table than what I have on the history table. And that's great. This is a really good example, right? This is a great place where I'm going to have a lot more data in the history table. That's why you see me creating a column store index here, right? Depending on the amount of data and quantity of data that's in the actual temporal table, which is probably my more OLTP table, I might not be doing that. I might not need a column store index here. So let's do some inserting and updating of data and kind of see how that looks. So I'm going to insert into my temporal table here. And then we're going to go select out of the temporal table just so that we can see how the changes get stored in here. And I'm inserting some stuff from this stored proc here just to kind of get us some data inside the temporal table and see what's in here. And what I come back with is there's 18,774 rows inside the table. I've got my business entity ID, first name, last name, city, state, and then of course I've got to have my system start time and end time to figure out when these records are valid. But what you'll notice here is, if I can get this thing to scroll down properly, if you look at the system end time, check out these dates. So all of these are the same. Now they're not all the same all the way down. Right, if I continue to scroll through the data set here, I should eventually be able to, somewhere in these 17,000 records, I'm going to find some stuff that doesn't have this particular date on it. But look how many do have December 31st of 9,999. Right, eventually I'm done scrolling. This is getting boring. Right, so there's a lot of records I want to scroll through here. What this means is this record is currently valid. So we're setting the date out as far as possible. That way we know that this is valid. So that means this is a current record, right? If there was a different date in here, then that means it would have been a historical record that had been, had an update or an insert or deleted or whatever the case may be. So that's one thing you can note when you're looking at your result sets of your data is when you look at the end time, if you see this December 31st, 9,999, you know that this is a current record because we've just flat set the date out as far as we can. So there's some interesting things about the data set. Let's keep digging through the data set a little bit more. Let's take a look. We're going to look up a person. So we're going to look up Mary Navarro. We're going to look her up in the temporal table and see what kind of data we get back from her. And we can see that she lives currently in College Station, Texas. And this is a current record because I see that wacky date here again. And she probably moved there starting on December 5th of 2021. Let's do some updates though. Let's say she decides she's going to move and she's going to move to Seattle. So I'm going to update my table and I'm going to change her city and her state to Seattle, Washington. But you'll notice that I spelled Seattle wrong. I did that on purpose, but let's run this and we're going to take a look at our result set. So when we query the temporal table, sure enough, our update is successful. We do see that we were able to change it to Seattle, Washington. All right, that's all I changed. We didn't change any dates. But then I realized, oh man, I put 2 E's in there. I messed up. I got to fix that. So we decided, let's go in and make an update. So I'm going to run this other update statement. And this is just changing the city back to Seattle spelled properly this time. Now let's go in and take a look at what we see. And you'll notice that I'm querying my temporal table here, but I'm using that new syntax called for system time all, which means that I want to grab all records where the first name is Mary and the last name is Navarro. And when I do that, what I end up seeing is the initial record where she was in College Station with a start and end time. Same where I had Seattle, but I spelled it wrong. And then we also see over here the end time, meaning this is the current record, and it would be because here's Seattle spelled correctly. So this is kind of cool to be able to use this new syntax to be able to go in and say, I want to see all the records, both the historical records where some changes have been made, in addition to what the current record happens to be right now. Let's take a look at using for system time here. And I'm just going to do a little restore on my database here. Kind of refresh this here since we've made some changes. And let's go take a look at everybody where the state happens to be California. And I get back 4,439 rows of folks where they have California. And that's just grabbing all rows. And this is grabbing absolutely everything. Let's take a look at using the for system time all. If I grab for system time all, I get back 39,679. Well, why? Because up here, I'm querying the temporal table, which is the current table, not the history table. So even though I'm saying select star, it only comes back with 4,400 rows. When I change the syntax I add for system time all, this is going to include both the rows in the history table and the current table. That's why we get drastically more rows back. We get 39,679 back as opposed to just the original 4,000 rows. So this is really great, easy testing to use the for system time all. You'll probably see yourselves using that fairly frequently, just to go in and inspect your data, see what's going on, and kind of decide what type of queries you want to be able to run. For system time as of allows me to say, go grab me everybody that lived in California as of December 16th of 2015. When I run this, I get 4,444 rows back. Some of them are going to be current, right? I see the 9,999 here. And then I'm going to get some rows back that are not, that are coming from the history table. So it's really easy for me just by looking at these dates to figure out which ones are considered to be current and which ones are coming from the history table. A very large majority of these rows appear to be, as I continue to scroll here, from the current table. Down toward the bottom, we'll start to see some stuff that is current. The next piece of syntax that's interesting to look at is looking for system time, and I'm looking for anything between December 1st of 2015 and December 16th of 2016 for folks that live in California. So the first thing I'm doing is I'm just grabbing a count from the history table where the state's California and the system start time equals this exact time on December 16th of 2015, just to see how many rows are actually there. And what I get back is 610 rows are in the history table. And this is cool because this means that I can still treat the history table from a read-only standpoint. I can still use this and query it directly. I don't have to use all these system functions if I don't want to. If I wanted to just see the history, I can do that directly using, going direct to the history table. If I select the max system start time, I do see that the max here is December 16th of 2016 at 1827 in order to grab all of the rows that happen to match. So I know we're kind of getting toward the end of our time. The last one here was just kind of showing some of the other statements between some of the contained statements that we can use. So I would encourage you to go look these up. These are all very well documented to use some of these. And I've just got some examples here that we didn't quite have time to get through. I was trying to see if there's anything else in here that would be really, really compellingly interesting to see. But most of these are all just examples of going in and querying the data and actually using this stuff. The only last thing that's kind of interesting is I had mentioned something about hiding using hidden columns. And you'll notice here that if I grab person temporal history, this has the start time and end time. If I use this add hidden on there, and then I run the query, guess what? Those columns are gone. So you can actually hide those columns. So it's entirely possible that you want this to be a temporal table. You're required to have those date time columns in there to be able to, use this versioning, but you don't want users to see it, or you don't want the app to see it. We can go in and hide those columns. That's probably the last kind of interesting thing, that all you have to do is add this add hidden. Next thing you know, those columns are no longer here in the result set. All right. Now, if you query the temporal history, if you query the history table or use one of the functions, you will see those come back. But just querying the temporal table itself, like your regular code would, you can hide those if you so choose. So Kenny, that puts us at time here. I think that puts us in really good shape. I think I was able to show everybody kind of all the cooler pieces of this. Does anybody have any questions as we finish up?
I don't see any more questions in the chat. I'll give folks a couple more minutes. This is really neat, Ryan. Thanks a lot.
Yeah, sure.
And if you don't mind, if you'll email me a link or a copy of this script, if you can, I'll include it when I get the video uploaded tonight or tomorrow, so that people can have it. That would be awesome.
I can do that.
Thank you.
No problem.
Yeah, no, I don't see any more questions coming in the chat. So thanks again.
All right.
And we'll try and do this again next month.
Sounds great. Thanks, everybody. Have a great week.
Thanks. Bye-bye.